I'm going to go over free response question number 3 from the 2022 AP Calculus BC exam. And we have a function f being defined as a differentiable function on 0 to 7. And we have a graph of the first derivative of f right here. And we have an initial condition, f of 4 is 3. And we have to find f of 0 and f of 5. Well, since I want to find f of 0 and I know f of 4, that suggests me to take the integral from 0 to 4 of the first derivative. And the reason I want to do that is because by the fundamental theorem of calculus, we know that this is equal to f of 4 minus f of 0. Right? Fundamental theorem of calculus states that for a definite integral, you can find an antiderivative, and an antiderivative of f prime is f, and evaluate it at the upper limit minus the lower limit. And we want to find f of 0, so what I'm going to do is add f of 0 to both sides and subtract this integral from both sides. So that tells me that f of 0 is equal to f of 4 minus the integral from 0 to 4 of f prime of x dx. All right, well, we know what f of 4 is. It's right here. And we can evaluate this definite integral based on this graph. So we're looking for the integral from 0 to 4. Let me pull out some colors here. Let's use red. Why not? So the integral from 0 to 4 means we want the area under the curve. So in other words, we want this area right here. The area of this little semicircle. We know it's a semicircle because they told us that in the problem. All right, so this is a semicircle. How do we find the area of the semicircle? Well, we know that if this is a whole circle with radius 2, it would have area 4 pi. The semicircle is just half of the whole circle, so it will have area 2 pi. But it's below the x-axis. So that means that the area of the semicircle is negative 2 pi. All right, let me switch back to the black pen. All right, so that tells me that f of 0 is equal to f of 4, which is 3, minus this integral. The integral from 0 to 4, we just worked that out, is negative 2 pi. And here is our f of 0. Now we have to do f of 5. We're going to do a similar thing. We know 4, we want 5. So we're going to look at the integral from 4 to 5 of f prime of x dx. And again, this is going to be equal to f of 5 minus f of 4. And so to get f of 5, I can just add f of 4 to both sides. So that tells me that f of 5 is going to be equal to f of 4 plus the integral from 4 to 5 of f prime of x dx. And again, we can work this integral out. So we're looking for the area under the curve of f prime from 4 to 5. So in other words, we're looking for this area of this right here. And we're told that this is a line segment right here. And let's see, to get from this, we go from up 2 over 2, because from this point to this point. So the slope of this line segment is 1. So that tells me that this is, well, we know that this is 1. And, well, if the slope here is 1, if this point is 4, 0, that means I have to go up 1 over 1 to get to this point. So that means the height here is 1. So we have a triangle, right triangle, base 1, height 1. That means the area is 1/2. All right, so now we can get our f of 5. So we know that f of 5 is equal to f of 4 plus this area. And we know that f of 4 is 3. Let me get my black pen out here. So this is going to be 3 plus the integral, which we just worked out, is 1/2. And here is our f of 5. And we're done with part A. We'll move on to part B. So part B is fairly straightforward. We're looking for the x-coordinates of all of the points of inflection on f between 0 and 7. Well, what's a point of inflection? That's where the second derivative changes sign, or alternatively, where the slope of the first derivative changes sign. So here's the graph of the first derivative, so let's look and see where the slope changes sign. So here the slope is negative, 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 and then positive. So at x equals 2, we have our first point of inflection, so we'll put that down. X equals 2, and then, all right, so the slope is positive, 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 and then negative. So we also have one at x equals 6. So these are the only 2 points of inflection on this interval, and we can say that these points are where f double prime changes sign. And we'll move on to part C. So for part C, we have a new function defined here. We know that g of x is equal to f of x minus x, and we're looking to find the intervals on which g is decreasing. Well, when is a function decreasing? When its first derivative is negative. So let's go ahead and take the first derivative here. So taking the first derivative, we get g prime of x, and then on the right side, take the derivative, we get f prime of x minus 1. And we need this to be less than 0. So that tells me that f prime of x has to be less than 1. And we have a nice graph here of f prime, and we just need to know when this is less than 1. So it's less than 1 between 0 and 5. So g decreases when 0 is less than x, which is less than 5. And it doesn't say justify, it just says show the analysis, and I think we did that. So now let's take a look at part D, which I have on the screen here, because we're still dealing with this function g, and we have to find the absolute minimum value of g. Well, we know that the absolute minimum of a function occurs when its first derivative changes from negative to positive. So if we take a look at the first derivative, which again, we know that g prime of x is equal to f prime of x minus 1. And we want to know when this changes from negative to positive. Well, as we see here, g prime of x, we're basically taking the graph of f prime of x right here and shifting it down by 1. So what I could also do is figure out when f prime of x crosses the line y equals 1. In other words, crosses this line right here. And the only point at which that occurs is this one right here, where x equals 5. So that tells me that the absolute minimum occurs at x equals 5. But keep in mind, and I have a feeling this was a common mistake on the exam, is that we don't want the x-coordinate. We actually want the function value. Right? We're looking for the absolute minimum value of g. So what we want to do is find g of 5. Well, g is defined right here. It's f of x minus x. So this right here is going to be equal to f of 5 minus 5. If you recall from part A, we found out that f of 5 was equal to 3.5. Then we just have to subtract 5. So that this is g of 5. So this is the minimum the absolute minimum value, and then we have to justify this. We can justify this by saying g of 5 is the absolute minimum because x equals 5 is, let's see, do I have enough room here? Is where g prime changes from negative to positive. And that should be a fine justification, and that's it.